Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about the types and classification of clouds. In this lecture, we will be discussing on fog, frost and dew formation. So, what are all the contents we are going to discuss in this lecture? They are the conditions and processes for the formation of fog, frost and dew, and what are all the types of fog and frost, and what are all the effects and impacts of fog, frost and dew, and what is the significance of this study. So, these are all the contents we are going to discuss in this lecture. The first and foremost is fog, frost and dew formation is mainly occurred in the surface weather phenomena formed due to what process? It's because of cooling near the ground. The cooling process is one of the most important process in the formation of all these weather phenomena. It occurs mainly during which time? That is night or early morning. So, because of this time, what happens? The radiational cooling happens. So, in the daytime, there will be a influence of solar radiation. But during the late evening, what happens? In the night, there will be a cooling process. So, because of that, these weather phenomena occurs during night and early morning. So, what are the factors which controls these weather phenomena? The most important factor is temperature and humidity condition. So, the temperature and humidity condition of a particular locality mainly determines the formation of fog, frost and dew. And when the air reaches the dew point, that is, if the air is going to reach the dew point, what we have discussed in the previous lectures, that is, it attains the saturation. So, because of that saturation, it attains the dew point, and that dew point which enhances the formation of fog, frost and dew. So, if it's going to be a frost, it's below 0 degrees Celsius. So, what we have discussed, if it's going to be below 0 degrees Celsius, it will be in a minus condition where there will be a formation of frost and fog. If it's going to be above the freezing point, if it's going to be rises, it is a plus condition. Remember, it is a plus condition. There will be a water format. So, the dew formation will be occurring in that particular increase of the dew point, that is freezing point. It is most common in the calm winds, clear sky. Why it is most common in that is calm winds and clear sky? Because this calm winds and clear sky supports what? That is, it supports heat loss in that particular locality. So, in order to form all these weather phenomena, what is the major factor? That is the loss of heat. The loss of heat is the most important triggering factor for the formation of fog, frost and dew. First and foremost is fog formation. So, what is meant by fog? It is the visible aerosols. That is, what is meant by aerosols? That is the dust particles. And then the, what is that? That is sea salt and then polluted matters which is suspending in the air. So, that aerosols, that is the tiny water droplets or ice crystals which is forming near the earth's surface. So, in the previous lectures also, that is especially in the condensation lecture, we have touched upon the fog formation. So, in this lecture, we will be elaborating about that. That is, the aerosols are suspending nearby the earth's surface. So, because of that, what happens? The cooling process happens and it triggers the fog formation. The low-lying clouds, that is, we have compared to which cloud? That is low-lying clouds, that is stratus clouds. So, stratus cloud is low-lying clouds. It is strongly influenced by water bodies, topography and wind condition. So, what are all the condition which associates with the formation of fog? That is the water bodies. So, we have come across the ocean, which is the largest water bodies which enhance the formation of fog, and topography. If we climb higher in the hill station, we can witness this fog formation. And the wind condition. What kind of wind is required? That is the calm wind. The smooth, gentle breeze is required for the formation of fog. And it also reduces the visibility near the ground. So, you can see in this picture, that is the visibility, it affects the visibility. So, this is the major condition of the fog formation. If there is a fog formation in the locality, it definitely affects the visibility of the objects nearby. It affects the shipping, transport, aviation and warfare. That is, these are all the factors which influenced by fog formation. So, because of fog formation, that is shipping, transport and aviation is affected. So, if the flight is going to take off, what is most necessary factor? The wind or the climatic, that is especially the weather condition should be very calm and subtle. So, it should be supporting the takeoff of the flight, and during the landing also there should be a favorable weather condition. The fog is also the low-lying cloud, which we have discussed earlier, which is found nearby the Earth's surface. Unlike clouds, this fog moisture is often locally generated. If it's going to be cloud, it is stretched over the large extent of the area. But if it's going to be a fog formation, it is locally that is generated. So, it is a micro level processes which is happening in the Earth's surface, especially in the nearby the Earth's surface. The sources includes nearby water bodies, moist ground or marshes. So, these are all the favoring factors in order to form the fog condition. What are all the conditions for the fog formation? That is the high relative humidity. So, the relative humidity should be high, and then it provides why it should be high? It provides a significant moisture for the formation. So, the condensation process, what is most important? That is the humidity is most important, especially the relative humidity. So, we have discussed about various types of humidity, but this relative humidity is most important for the fog formation. The cooling of air to the dew point, that is the dew point, it should attain a certain level. So, this dew point, the cooling dew point is most requisite factor for the fog formation, and also calm and light winds, which in turn does not allow the air to mix. So, it was very calm. So, that was the really requisite condition for the fog formation. Without condensation nuclei, that is the fog formation is not possible. Not only fog formation, especially the cloud formation. The cloud and fog is more or less associated. That is, it requires the stable atmosphere support which persists the phenomena. So, this entire phenomena, that is the high relative source of air and high relative humidity and cooling to dew point, the evaporation processes which triggers the moisture condition, and then condensation nuclei and calm situation, that is calm or light wind which triggers the fog formation. So, these are all the prerequisite condition for the fog formation. More or less the formation of fog, frost and dew will be same. So, there will be a slight difference. Only thing is that the freezing point. So, in the upcoming slides you can understand what is the real concept. There are so many types of fog. The first and foremost is a radiation fog. So, the radiation fog, the name itself, we can understand that who is going to play an important role? That is the solar energy, that is the heating process. It is formed by land cooling after the sunset. So, if there is sun, it does not allow or permit the formation of fog, especially the radiation fog. So how it is formed? It with the help of infrared radiation in the calm, clear condition. The calm and clear condition is most important for this fog formation, that is radiation fog formation. The cooling ground, the cools nearby air by conduction. So the air nearby areas, what it will be doing, what process is happening there? So because of the air, cooling air, it have the conduction process, and because of this conduction process, it lowers the temperature to the which point? That is dew point. It lowers the temperature with dew point. It also causes the fog formation near the surface. So you can see the fog formation near the surface. The clear skies allow the maximum radiation heat loss. So we know that if the sky is very clear, it does not block the radiation incoming as well as the outgoing radiation. So because of that clarity in the sky, it supports for the fog formation, that is radiation fog formation. It's common. This type of radiation fog is highly witnessed in valley, low-lying areas where the cold air settles. So in the mountain and valley breeze, what we have discussed, the cold air, the cool air will be settling at the bottom of the valley. So this process is mainly because of cooling process. So that is the concept you can apply in this radiation fog. The next fog is ground fog. So the ground fog, so it is nearby the ground. The fog is formed nearby the ground. So you can see here the fog is nearby the ground. It obscures less than 60% of the sky. So the sky is obscured only less than 60% while this fog is formed. That is especially the ground fog is formed. Thus, it does not extend the base of overhead cloud. So you can see that it is not extending in the higher altitude. So the occurrence is nearby the lower surface, the ground level. So this is the most important difference between the other fog and then this ground fog. The commonly used synonym is the shallow radiation fog because it's very shallow in nature. So because of that, this name is given for this ground fog. The fog layers very close to the ground surface, and it also requires what? The calm, no wind condition. So there should not be any wind influence. The wind or the place, the locality should be very calm. It is also controlled by terrain and local cooling. So the terrain and local cooling, because of local cooling, this ground fog appears in that particular locality. The next type is advection fog. So what is meant by advection? The advection is something it's going to drag or it's going to carry along with it. What it is going to carry? So we'll see that is it forms when warm moist air moves over cool surface by advection. What is carried? That is the major factor, wind is carried. So the wind is carried along with to form this advection fog. The air is again cooled. The process will be very similar. The only thing, the minor difference will be there for all the types of fog. The air is cooled to the dew point and produce fog, and this fog is common during warm front passage over snow covered ground. If the ground is very cool and if the ground is covered by snow, it triggers this process, that is the formation of advection fog. Frequently it is observed near the coastal region. So in the coastal region you can observe such kind of advection fog. It is also associated with the cold ocean current and onshore winds. The wind is blowing from the water bodies. So this coastal cold current means automatically it will be cool air. The surface of the water bodies will be cool. So the requisite condition is cool in nature. The cold condition is required for the formation of fog. So this supports for the formation of advection fog. The next one is steam or evaporation fog. The name itself, the evaporation steam, somewhat the heat is influenced in this fog process. That is, it forms over the bodies of water overlain by much colder air above. So here there will be above the stream there will be a cold air. So because of that influence, what happens? There will be a whirl formation, the spiral formation here. That is, it can cause these stream devils. Why it is called as a stream devils? Because of the spiral activity. A small weak whirlwinds, that whirlwinds is called as the stream devil. Over the water or wetland forms in this stream fog, or it is also known as evaporation fog. It appears like a rising stream, hence it's called as stream fog. This is also, you can see in the picture, it appears or rise above the stream like a steam. That is, steam is the, if you heat a water in a pan, what happens? The steam evaporates. The same way from the water body, the steam is evaporating. So because of this process, this fog is known as steam fog. It's common over lakes, rivers and seas. So the water bodies are most favorable factor which triggers this fog formation. It occurs mainly in winter season. So all these fog, frost and dew occurs in the cold condition, that is especially the winter season. And it's much, when the air is much colder than water, if the air is more colder than water, this kind of fog will be formed in that particular region. The next one is lake effect fog. That is, in the name itself, it is the occurrence of this lake effect fog will be nearby the lake region. It forms when the cold air moves over the warm air. So we know that the warm air, what happens? The warm air will be rising up and the cold air will be suppressed, it will be coming down. So because of this movement, this lake effect fog is formed. It is also known as ocean effect or bay effect snow over a salt water. If it's going to be a condition in the salt water region, so this fog is called as snow effect or bay effect snow fog. It is different from dense fluffy advection fog on the land. So in the advection fog, what we have discussed, it's carrying the wind. So the same way, it is not similar to that advection fog. It is somewhat different in the appearance. It is not such dense or fluffy in nature as advection fog. Usually the less dense and shallower is this characteristics of this fog, and it's common in large water bodies in the cold weather. In the cold weather, you can see this kind of fog nearby the water bodies, especially the lake and salt region water bodies. The next one is frontal fog. That is, it is formed like a stratus clouds. So stratus clouds, so the lower region, low level, low altitude region. So this raindrop from warm air evaporates into cooler air near the surface and causing the saturation. So because of the warm air, cold air come together to form the saturation point and dew point, so this kind of frontal fog is emerged in that particular locality. It is a result of a very low frontal stratus clouds subsiding to the surface level. So it's subsiding to the surface level. So this was the characteristics of frontal fog. It occurs in the frontal passes without any lifting agent. There is no other agent which is going to lift this air. It automatically lifts by its own efforts. So this was because of warm and cold air. So in the frontal region, the frontal air mass, what happens? Warm and cold air masses, the boundary. So that same concept you apply here for the fog formation. The next one is ice fog. That is, it forms at a very low temperature, often below freezing point. So here is the catch. Ice fog, because of ice solidification, it's below freezing point. It can result from other fog mechanisms or exhalation of warm moist air. By what? By which agent? That is animal herds. So if there is an animal herd in a region, because of the breathing processes, the exhalation, the warm condition and the liquid formation, the vapor formation, this kind of ice fog happens, that is formed in that particular herd region. So this is the main cause of this ice fog. Associated with diamond dust, tiny ice crystals falling slowly. So how it looks like? The ice fog looks like a diamond dust. So it was a very minute diamond dust which is falling from the atmosphere. It occurs even under the clear blue sky condition. So automatically, if it's going to be a fog, frost or dew, what is the condition? Clear sky. So the clear blue sky is requisite condition for this formation. It produces halos, sundogs and other refraction effects due to the airborne ice crystals. So ice crystals, so because of its characteristics, the ice crystals, it reflects, it scatters its light. So because of that effect, what is formed? Halos, sundogs. So all these process forms because of this airborne ice crystals. The next one is freezing fog. So in the picture itself, you can see that how frost is the condition, how much freezing happened in that particular region. That is the rime formation from the super cooled water droplets. So the water droplet should be much cooler than other fog formation. The droplet freeze instantly when they touch the surface. When it's going to touch the surface, automatically it will be freezed. Because of that freezing condition, this fog is known as freezing fog. It creates white icy deposit on exposed objects. So you can see here in the shrubs and then in the trees, you can see the freezing condition. So this was the situation in that particular region. In which fog? That is freezing fog. Next one is precipitation fog. It forms when precipitation falls into the drier air. So that is above the clouds. So the precipitation, that is a rainfall. So it may be in any form. So because of that precipitation falls, this precipitation fog occurs. That is the liquid droplets evaporate into water vapor. In the common condition of the precipitation formation, what happens? That is the liquid is evaporated and it transforms into water vapor. The same condition is happening here. The vapor cools to dew point and condenses and forming this fog. So as usual, what process happens in the water cycle, the same thing happens in this precipitation fog. The next one is hail fog. That is, the hail fog forms near the significant hail accumulation. So there is a hail storm. We heard about the hail storm. So that is happening in this locality. That is, it's caused by decreased temperature and increased moisture. So the requisite condition is the temperature should be very low and then the moisture content, humidity should be high in that particular region, especially near the surface. It results in the saturation in the shallow air layer close to the ground. So near the ground level, the saturation happens. Because of that, it triggers this hail formation, hail fog formation. It occurs when warm humid layer lies above the hail. So there should be this prerequisite condition, that is a warm and humid layer above the hail condition. It favors the light wind. It is mainly favored by the light wind, that is a gentle breeze. The next one is the upslope, downslope fog, or otherwise it is also known as hill valley fog. So this is more similar to the that is the valley and that is hill and valley breeze. So we have discussed in previous lectures, the same concept is applied here. It forms when moist air ascends mountain slopes. What happens? The moist air will be rising in the mountain slopes. So that's the same concept concept is here, and cooling adiabatically and condense into fog. So once it rises, the warm air rises, the cold air will be coming down, and the adiabatic process happens, and the cooling process is happened at the floors of the either it may be a hill, downhill slopes, or it may be a valley bottom. So this kind of process is happening. So this triggers the formation of upslope or downslope, or it is also known as a hill valley fog. That is, it also causes a reduced visibility on the hill slope and passes. So while we travel in the hill or passes, we can witness such kind of fog. So this hereafter you can say that it is a hill or valley fog. It requires a gentle wind to push the air upward without turbulence. Just it's a triggering factor. Light gentle wind is required to lift it up, lift the air up to the higher level. The next one is the effects of fog. So far we have completed the types of fog. Now what is the effect of fog? It reduces the road visibility, making the driving hazardous. If it's going to be a foggy condition, the transportation, especially the travel, is much more affected, and it causes delays in the transport, and because of that what happened? The flight will be delayed, train will be delayed. So because of fog condition, it increases the risk of accidents due to poor visibility. So because of the visibility effect is not proper, there will be an occurrence of accidents. It disturbs the aviation operation, especially in the takeoff and landing process. It also affects the daily life. So if it's going to be a foggy nature, so automatically our entire daily routine will be collapsed because of this condition. So these are all the adverse effect of fog. The next one is frost. The frozen form of dew, also called as frost. It is a frozen state. It is not in a liquid state. It is a frozen state. So you can see in the picture, so it is frozen state. It forms when the temperature drops below 0 degrees Celsius. So if it's going to drop it adversely below 0 degrees Celsius, this frost is formed. The water vapor deposits directly as the ice crystals. There is no intermediate processes. So if it's going to be directly changing into solid form, what is that process known as? That is sublimation, and it is also known as what? It is also known as the solidification process. So in the upcoming slides we will be discussing it. It occurs in the clear cold night with calm condition. Where there is a cold night, clear sky and calm condition, frost will occur. It appears with white crystalline layer, and where you can see this kind of frost, not in only the grass or leaves. In all the objects you can see this frost frozen in the floors and other objects. What are all the prerequisite conditions for the frost formation? That is clear sky, which enables the maximum radiation heat loss, and then calm wind. Why it is needed? In order to avoid the mixing of air. It reduces the mixing of air and it allows the surface cooling, and the temperature will be below freezing point, that is below 0 degrees Celsius, and high humidity is required for this condition, and strong radiation cooling causes this rapid drop near the ground surface. So all these processes happen near the ground surface, not in the higher altitudes. The next one is what are the processes involved in the frost formation? That is, rapid surface cooling is most requisite condition, which lowers the temperature quickly after the sunset. That is late evening and early morning. That is night time is most important time for the frost formation. The air reaches the frost point below freezing dew point. So this is also one of the prerequisite condition, and water vapor deposit directly as the ice crystals on the surface. So without that is transferring into liquid phase, it directly solidifies. This process is also known as the deposition or solidification of vapor. So this was the other terms called for this direct change of gaseous state to the solid state. what are all here in the frost also we have different types of frost. They are radiation frost, advection frost, hoar frost and black frost. So these are all the types of frost. We will discuss one by one. The radiation frost, it is caused by the night cooling of ground and air. So the during the night time it will be freezed. The ground will be freezed. So this was the condition of this radiation. So in the radiation fog also it is more or less similar. Fog also we have come across all these processes. The same thing happens in the frost, but the change is somewhat the degree of temperature will differs. The minute degree temperature differs. It occurs during calm and clear nights. It has also localized occurrence. It is not stretching over a vast region. It's localized. Somewhat micro level change will be happening in a small area. It is common in valley and low lying region. In the valley region and low lying region you can witness this radiation frost. It's mostly seasonal, occurring in winter months, as it requires the excessive cooling condition. It forms in the winter season. The next one is advection frost. That is, it's caused by arrival of cold air masses that is moving into an area. That is, cold air masses is moving into the area. Because of that, the advection happens. The wind, it carries the same thing. You can check the terms of the fog as well as the frost. The types, it also much more similar. It covers a large region, but in the radiation frost what we have discussed, it covers only small region, micro level region, but here it's a large region. The strong wind often present during the formation, and it also causes severe damage to crops and vegetation. So because of frost condition, what happens, it especially in the advection frost, it damages the crops and vegetation. Usually it lasts for the extended period. So if it's going to be happen in an hour or a day, somewhat it can be managed, but if it's going to be a long duration, it adversely affect the that is especially the agriculture, vegetation and plants. Next one is hoar frost. That is ice crystal form on the surfaces through vapor deposition. So you can see here the ice crystals have been deposited in the vapor situation, okay, in the condition of vapor. That is, it have a feather-like delicate structure. So you can see here what is the difference between the radiation frost and then the advection frost. It was entirely frozen, but here it was like a feathery condition. It was very light feathery condition. It occurs in a very cold humid condition is a prerequisite that is a condition for this formation, that is hoar frost formation. It often decorative in the appearance, but it's very harmful. While looking into this frost, it was very much pleasing to see this frost, but it is very much harmful. It is dangerous one. The next one is black frost. The black frost, the name itself, you can witness that no visible ice crystal. See in this picture, there is no frosty condition in the road, but there is a frost occurrence in this particular region. How? That is, it results in a sudden temperature drop below freezing. The temperature have been dropped below freezing point. So because of that, the frost have occurred in this place. Extremely damaging to the crops. So it is a silent killer. It's extremely damaging the crops because of this non-visibility. It can kill the plant quickly without visible frost. And then it is a rare occurrence but severe in impact. It is not often occurred in the regions, but it occurred in a rare case, but it's very it produces very adverse effect in that particular region. What are the effects of frost? So in the picture itself you can see that what is the effect of this frost. That is, it causes crop damage affecting the farmer's livelihood, and it leads to the reduced agriculture yield and food supply. So if it's going to be crop, it is touching crops, adversely it affects the agriculture, then economy. So like that, it is a cycle, it's a connectivity of chain. Why causing of bursting of water pipe? Because of freezing condition. Because of freezing condition, expansion and contrast, the water pipes will be burst because of this frost condition. It results in transport disruption because of icy roads and poor visibility, and it causes a significant economic loss in a multiple sector. The next one is dew. So that is, the dew is a little bit different from fog and frost because of the freezing condition. That is, it's condensed water on the surface. The condensation takes place, but what happens? Like grass, leaves, and object, you can witness the droplets of water vapor in the leaves, glasses, and then in the flowers. You can witness in the early morning, you can see this dew formation. It forms during nighttime cooling. Because of the nighttime process, we can see this one in the early morning. It occurs when the temperature remains above the freezing point, that is above the 0 degrees Celsius. Air reaches dew point and causing condensation. So all the other processes similar, only this is the catch you have to remember. Appear as a tiny water droplets on the exposed surface. Wherever the surface it's coming across, there will be a water droplet. So that is known as a dew formation. What are all the prerequisite conditions? The same conditions like clear sky, which allows the maximum loss of heat by radiation, and calm winds, which prevents mixing of warmer air, and then high humidity is also required, and then rapid surface cooling is requisite as a fog and frost, and the temperature remain, this is the change here, above freezing point, which favors the dew condition. Next one is, what is the processes which is involving in the dew formation? Earth loses its heat by radiation after sunset. So after sun only all these processes happening. That is, the surface cools rapidly under a clear calm condition. Air near the ground also cools and reaches the dew point. And then what happens? The vapor condenses and cools surface and form the cool surfaces, and the dew forms on the object. It may be in the grass, or it may be in the leaf, or it may be in the soil. What is the importance of dew? That, see, it's exactly opposite to the frost. It is very much supportive. This dew is very much supportive. That is, it supply moisture to the plant through dew deposition. Because of the deposition in the leaves, it gives the moisture to the plant growth. And especially it's useful for dry and arid region. If it's going to be arid region, there will not be a water, sufficient water. So this is the supplementary factor which enhances the growth of vegetation. It supports the agriculture processes, and it also reduces the plant water stress because of the dry periods. In the dry periods, it supports for the agriculture processes. It indicates the local moisture availability in the environment. So in the environment, it indicates it was the moisture content is there. So that is the main point of importance of dew. So what is the importance of this study? So the entire fog, frost, dew, why we want to study? Why we want to understand these concepts? That is, accept the visibility and transport, it causing hazards. It also influences the agriculture which supports the dew. In the agriculture, you can see the contrast. That is, if it's going to be a dew condition, it is very supportive. If it's going to be a frost nature, it's going to be a damaging one. It indicates the atmospheric stability, whether the atmosphere is stable or instability. So that can be identified with the help of this study. It impacts the daily weather and human activities, and it also reflect on the local climate and surface processes. So it entirely affects all these things and support the processes also. To sum up with this entire lecture, that is, fog, dew and frost is a weather phenomena which is happening during the calm, humid condition. The fog develops near the ground and reduces the visibility, while dew form above the 0 degree Celsius, frost below the freezing point on the exposed surface. So these phenomena significantly influence agriculture, transportation network, and every day of human activities. I hope you understand the concept of fog, frost and dew formation. In the upcoming lecture, we will be discussing on the formation and processes of precipitation. Thank you.